Good day guys, welcome to today's lesson on Start Pro Connect Edition. Today we are going to be designing the dog leg staircase, and I've made a very simple sketch on AutoCAD. So I have this is the plan, this is the elevation. So I'm easily going to model this on Start Pro. So I expect that if you've been watching my video, to be easy for you to model now. So we'll go with this. So the first thing is my origin, okay, my node cursor. So Ctrl+C, Ctrl+V in the X direction 1 meter, okay. Then this translational repeat in the Z direction, number of steps 2. The first one is -2 and the next one is -1, okay, and okay. So once I'm done with this, I light this translational repeat in the X direction 2. The first one is 0.2 and the next one is 1, okay. So I have this. Then once I'm done this Ctrl+C, Ctrl+V in the Z direction 1, okay. So I'm done with that view. Then you go to your plates, display, or rather top view, then geometry, add plate. So when you're adding plate, make sure you add it either anti-clockwise or clockwise. So me, I'm adding mine clockwise. Yes, yes, and this last one, okay. Now I'm done with that. Next thing I need to do now is, okay, I don't need this node here. That's node 6 and 9, these two nodes. Then so once I check my whole structure, I can see that it's not behaving like, it's not showing like a staircase. I didn't model it correctly like a staircase. I need to elevate this. So to easily elevate it, I'm going to raise some nodes, and let me tell you the distance from this point to this point is 1.5, and from this point down to this starting point is 1.5. So that means from the ground to this level is 3 meters. So first thing now I'll do is select my node cursor, this, and this, right click, move 1.5. So those nodes I selected, these are the nodes, these nodes here and these nodes here. So the next node I'll be selecting are the nodes within this range. So okay, yes, then the next one will be 3, 1, 2, 3, 4, move, or you can edit it from here while changing it to 3. So move y 3 meters, okay, yes. So you can see this. So the next thing I'll do now is assign property. So I want to assign a thickness of 0.15. that is my waist, because in Start Pro is mostly the waist. In staircase is the waist we design, and when I mean waist, this is what I mean on my waist. This is the riser, the going, and this is the waist where this riser and going will rest. So this is where my reinforcement will be, okay. So I hope you get that. So assign to view, that's been assigned. So the next thing I'll do now is right click and generate plate mesh. So I want to division 5, 5, 5, 5, okay, quadrilateral, yes, okay. So I know there is going to be support, so this place is continuous, but this place is starting from the ground, so here will be pinned. So support, create support, fixed, add, create support, pinned, add, okay. So assign, use cost, go to the front view from the top. So this is the pin, this is the pin part, this. So assign to selected nodes, assign, and this is the fixed part. Click it on the fixed, highlight and highlight. So assign to selected nodes, assign, yes, okay. So if there's a beam here, so let's assume, okay, no, we're not assuming, because from the plan it didn't give us a beam. From this plan there's no beam stopping here. So but in case if there's a beam, you cannot put your support at this point. If there's a beam, you can put your support there. So I have this, I have this. Next thing I'll do is my loading, load case details, add. First one is the dead load, add. Next one is my live load, add, close. So under my dead load I have my self weight, add. Then I have my plate load, that is finishes and the going risers and the thread, everything. So plate load from calculation, I already have it as 3. So add, close, assign to view, assign to view, assign to view, assign to view. So I've done that. Next thing is my live load, add. So I'm assuming I'm designing for probably 5 kilonewton per meter square. So plate load 5 kilonewton, add, close, assign to view, assign to view. So now go back to the display hole structure. Make sure the loads are going down, are going on the plates, not that they are coming from the bottom, they are going from the top. So this is going, yes, is correct, this is also correct. Okay, so we are good to go. So the next thing we do is load case details. So add automatic load combination. So I'm using the British 8110 generate. So I'm only interested in 1.4 and 1.6. So add. But if you're not using the British code to design, you can also use the Euro code, and you check my previous video, which I will drop in the description, on how to create load combination with Euro code. Okay. So the next thing we do is go to analysis, define command, add, close. So run your analysis. Yes. So while we wait for our analysis to run, let's see the results. So we have 0 error, 0 1 in 0 nodes. So we can go to the post processing. Yes. So I'm only interested in the ultimate load combination. Okay. So you can see your deflection, this way to deflect. Yes. Okay. So after that, next thing I'll do now is I need to check my plates, my maximum absolute stress. So you can see it's fully stressed. So I can see with 150 is highly stressed. So I'm going to increase the strength of concrete. And let's see what will happen if I reduce the strength. Let's see what will happen. Okay. So going back to this mode, utilities, command file. So it brings out the command file. So I want to edit it from the command file. Okay. So go to property. So you can see the thickness. I want to try 100 mm, 0.1, save. Yes. So run my analysis again, and let's see what, and our stress there was 6 point something. So let's see what it will give us if we use 100 mm. So wait for the analysis. So 0 error, 0 1 in 0 node. So go to the post processing. Okay. Apply. Okay. So see the way it's displacing. Wow. Let me reduce it. So plate this maximum absolute. So it's almost times 2. So that means 150 or 175 is sufficient. So I'll go with 175. Try 175 for my thickness. So go back to my utilities, command file, and change it to 175. So save. Yes. Then if you don't know how to change it to the command file, you can also come back to your property and change it to your property. So once I'm done with that, I'll run my analysis, and from there I'll design, pick the most stressed plate and use the reinforcement for the most stressed plate for all of them. So 0 error, 0 1 in 0 nodes. So go to post processing. Okay. So plate. Yes. So maximum absolute, you can see it starts reduced. So if you want to use lower strength of concrete, you can also increase the thickness, but I'm okay with my 30-35 Newton per for my staircase. So apply. Okay. So this is the stress. Okay. So you can see it from the top view. So this is the contour. So you can look at this red part, this parts. Okay. Yes. So you can see it. Then you can now go back and see your moment. MX. So the MX direction, we have 7 and we have -6. And let's see the MY. Okay, we have -25 and this. Okay, so which one is -25? This. Okay, again, or the sagging moment at this point. Okay, then the sagging moment, we have about 10 point something. Okay, 12.8. Yes. So what I need to design now is, I already know my most stressed plate. I know this, and probably this are the most stressed plate. So new view. So I'll just design this plate and use the worst reinforcement for all through. So go back there, go to design, choose your concrete design code. I'm using 8110 just for the plate. Then define parameters. For my clear, I want to use 15 mm. Add. Then for my FC, I want to use 35,000. Add. Then for my steel, I want to use 500. Add. Close. Okay, so that's concrete design. Assign to view, 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 assign to view. So I'm only going to design these 4 plates. So I'll use the reinforcement for my detailing. So the next thing I'll do now is choose, do I want to design it as a slab, column? So do I want to design it as a beam, column, or slab? So I'll choose slab. So it's going to design for the MY and MX. So add, close. So assign to view, assign, yes. So you can press Shift P to bring out your plate number. So I can see plate 967, 102, and 41. So I'm going to check it now. Run analysis, yes. It's because it's heavily loaded, that's why it's fully stressed. So go to the output file, yes, done. So go to concrete design, yes. So I can see for my plate 9, it's telling me to use Y12 at 200 center to center, bottom. And now I want to explain something in the finite element on start probe. If Z is facing, whichever direction Z is facing, that is the top. So my Z was facing the bottom, so that means that is my top. So it's telling me to provide at this point for you MY bottom, so that is top. Look at the moment. So that's plate 9. Let's look at plate 9 here. Plate 9. So it's telling me to provide at the top hugging moment. That's why it's negative. So M bottom negative. So it's telling me to provide Y12 at 200. So area of steel required is 402. So still provide Y12 at 200 is sufficient on top. Then what else again? We have another plate. Plate 41 is telling me plate 41. Sorry, there should be here. Plate 41 rather. Okay, so MY on top and is this. So it's telling me to provide at the bottom. So look at plate 41. Bottom, yes, we know it's bottom here in the Y direction. Bottom. Same with 67 and that. So let me see the highest, the worst company, the heavily reinforced. See Y12 at 200 and Y12 at 200. This is also top. I'm still going to provide the top. Okay, so I'm going to use Y12 200 top and bottom, and to get my distribution will be, okay, let me search for calculator here. Calculator. So to get your distribution bar, it is 0.15 times the thickness of your concrete, 175. So once you use this, 0.15 times 170, 0.1 B, 175 times 1000 divided by 100. Okay, so we have 262. So we can use Y10 at 300 center to center, or Y10 at 250 center to center. So you check your steel table. So another way of checking. Welcome back. In the previous part, we talked about the design. In this part, we're going to be talking about the detailing of a staircase. Now, to detail a staircase in the plan is similar to that of a slab. A staircase is just a slab, a slant slab. So we've done this after with the starter bar, the flight bar, and these landing bars. Then I have this one again with the distribution. This is the top distribution. If you look at it, 4H 1003 at 250 center to center, top distribution. Then this is the bottom bar. So you can look at the bottom bar going from this point down to this point, and for the bottom bar, this is the bottom bar, top bar cranked, and top bar distribution, bottom bar distribution. So it's just similar to that of a slab. You call it out and you see what you're looking for. So we are going to be cutting the section along this panel, along this part, that flight. So I'm going to turn off my rebars and my call outs. Okay, yes. Now, so I'm going to be counting my risers and going, and my riser is 150 and my going is 250. So from the ground, 1 2 3 4 5 6 7 8 9 10. So we have 10 from the ground. So let's start. Get your line. So this is the ground. Okay, so you can just put any length in the ground. You're going to use broken line. Then my riser 150, going 250. So you can continue riser going, but no time, so I can just copy and paste. So highlight this, copy, then paste. So you can okay, so 1 2 3 4 5 6 7 8 9 10. So we are the final spot. So I can get my level length, maybe 175. Okay, so offset it by 1000. Yes. So extend. Okay, so break this. So offset again, the thickness of the waist, offset 175. Sorry, 175. We'll bring it down. Similar with that also, this ground floor. Okay, so the next thing we do now is to draw a slant line from this place down to this place. So after drawing it, I need the waist of my staircase, and for my calculation it was 175. So offset 175 and bring it down. Okay, so the next thing I'll do is I'll join these two together and this. Okay, so I'm done with the almost with the elevation already, so I can break my line at any point here. So maybe I can break it here, somewhere here. Okay, so this is my line and this is the top. So at this point I have the support here, that is this beam. So at this, there's going to be half landing beam there. So I'm going to put my half landing beam, which is 230 by 450. So offset 230. Okay, then offset 450, offset 450. Bring this down. Okay, so chamfer. Okay, so we have this. So I can trim this point off. Yes, I can trim it off. Yes. So the next thing is I need to put my rebars now. So at this point I'm going to start with my, okay, let me start with this point here. So I'll change my layer to, let me turn on my layers now. Turn on my layer. So I have my bottom rebar, and my bottom rebar goes like this. Okay, let me offset. I'm using concrete cover of 15, so offset 15. Let's say 20, offset 20. Okay, so extend, offset under 20 again. Yes, yes, under 20 for the top, and this also. Okay, so chamfer, this also chamfer. Okay, so I'll change my layer now, change it to bottom rebar, and this is top rebar, top bar. Okay, so next thing I need to do is this slant one also, offset 20. Okay, so this is it here. Sorry, match property. Okay, there was a mistake in the previous part, so I've corrected it at this point now. Okay, so the next thing I do now is I will extend it to this point. So extend this. Sorry. Click this, then extend. Okay, so this is what I want to extend. Yes. So I'm also going to bring this one down. Then before that, I'm also going to bring my starter bar, or set my starter bar 20. Okay, so after doing that, the next thing I'll do is my top bar. So it needs to go somewhere like this. Okay. Sorry. Okay, then I can bring it in. Sorry, turn this off. Something like this. So you need to calculate the length at which it should go in. So match property, trim. Okay, so I have this. So I can also bring it a little bit down. Okay, so trim it. Yeah. So this also, I'll bring it down to this level. So bring it down from the particular distance. You know your 1.5 of the distance, but I just use this for rough work. Then I'll bring it to the particular length. Probably, let's say this point is okay. Okay, sorry. Let me straighten this. Okay, a little bit. So I'm done with match property. So trim. Okay, so I have this also. I can extend this down. Yes. Sorry. Click this, then extend. Okay. Okay. So the next thing I'll do now is put my distribution bars in this direction. So let me just use donuts. The donuts 25, 25. Okay, so I'll copy it. Copy and paste, then distribute it. I need one here. I also need one here. I actually need one at this point. I need some here, and I need at the bottom here. Okay, so let me use this bottom here so that you understand what I'm doing. So the next thing I do now is, since the spacing of my distribution bars are 150 and 250, so I'm good to go. So array parts. So I'll select the part. This is the part. Escape. Click this and change it to 250. Okay, so I'm done with this. Similar with this too. Select the part. Change it to 250. Okay, similar with this. Okay, change it to 250. Then this also, change it to 50. Then last but not least, this part to 50. Okay, so once you are done with this, the next thing you do is now you have to call out your bars here. So like this dot, now this starter bar, our distribution here for the bottom, distribution for the bottom is, this is it, and it is 05. So you put 05 down here, and for the top is 02, so you put 02 on top, 02. Then for this top again, that is this one here, this one, and the top distribution is 01, so you put 01, and also here. So let me copy small, let me explode this, so I'll copy 1. Okay, so you can do this, and let me explode it. Okay, so then it is there. Then for the top 01, then you can now call it out like I call in your normal slab section. So this is typical detailing of a simple staircase. Then once you are done, you also break this part out. And this time when you are breaking it out, this place will start from here, and there will be a final landing at this point. So it won't be a starter bar, it won't be something like a starter bar. So thank you for watching today's video. Please, if you have any question, you can drop it in the comment section. Thank you very much.